Surface finish measurement is the process of measuring the surface finish, or surface texture of a part. The surface finish of a part is the result of various manufacturing processes applied to the part. At a microscopic level, the surface finish of a part can be broken down into roughness and waviness components. Roughness is the closely spaced irregularities present on the surface of the part. Waviness is the widely spaced irregularities present on the surface of the part. The roughness and waviness components are superimposed together, contributing to the overall surface finish of a part. Surface finish plays a crucial role in determining the aesthetics, performance, and reliability of a part. For example, the body of a car requires a smooth surface finish to enhance the visual appeal of the car. Conversely, the brake components of the car may benefit from a rougher surface finish to optimize friction. A designer specifies the desired surface finish on an engineering drawing of a part, which serves as a guide during the manufacturing process. The surface finish of a part is measured after the manufacturing process is complete. The data from the surface finish measurement is used to calculate the surface finish parameters, which ensures the compliance of the surface finish of the part with the design requirements. The surface finish parameters also serve as a valuable resource for predicting the specific surface finishes achievable through different manufacturing processes.